We watch. Aku kumakan.
Hello.
क्या पार
Yes.
Ni kuanzia zi.
Niko na swali man.
Alright. Posizione sana kabisa. Tunakuja kumpata kijana wetu.
Kolokola kilio.
Rada magaish.
We can start our lesson from fours. I request that we all put our videos on. Now, you can give me a message, or you can, yeah, it's good if you give me a message so that we are able to move on well, especially addressing your areas of need, because as I know right now you are muted, because some of us are too noisy at home. So you can give me a message, you can carry up your hand so that I give you a chance to tell me where you want us to start. I know we are through with the syllabus, so this is basically it's going to be a revision session. It's going to be a revision session, and let us take it seriously because it is going to add value at the end of the day. Yes, you can inbox me or you raise up your hand, because some of us want to be able to adhere to the discipline of the class. They're going to make some noise. Mulu, I've received your message. There's an option I've given you whereby you can unmute yourself and then talk to us. But if you mishandle that option, I'm going to mute all of us or even remove you from the class. So when you want to talk, you want to ask a question or the topic you want us to cover, I have a book here, I'm listing them down so that we can know the areas we are going to tackle during these few weeks we shall be together. You can unmute yourself and then you ask your question. Or you tell us exactly where you want us to, what you want us to discuss. Victor Kimani, can you hear me? Are you able to unmute yourself?
I can hear you.
Okay, thank you so much. So let us have the order and the discipline that we need in this class, personal discipline, so that, and in case someone is misbehaving on our screen or doing anything, let us all join hands to play in the class so that we can have those who are serious to us idea. The lesson is on record. The lesson is being recorded for those who won't be able to join later on. So we don't need anyone to misbehave or do some mischievous activities during the class, so that those who are not with us can benefit after the lesson. So I hope that we are going to adhere to the self-discipline so that others can also benefit after the class. I'm still waiting for the areas, maybe areas or questions you want us to go through, because we are through with the syllabus as Form 4s. We are through with the syllabus, so maybe some areas or papers that you went home with or areas of concern. Maybe I might give you a topic, but maybe you are okay with that. So in case I get your areas, it will be very, very good. It will be very, very good, especially areas that are known. Yes?
Statistics.
Statistics. Samuel has suggested we do statistics.
Yes.
Okay. So Samuel, you keep on unmuted so that we can talk. Are you there, Samuel?
Yes.
Okay. Statistics, which part specifically?
Statistics too.
Statistics too.
Yes.
Do you have some concepts, Samuel, or from afresh? You just start afresh. Maybe I have two ways of approaching it. I can just go through the topic as we talk, mentioning some key concepts, and then we do an example on how we can handle those concepts. Or I just start afresh from the first page of that topic.
Yeah, that's the key parts. You can address parts, the key parts.
Or I can mention the section that are normally set or the key concept, right?
Yes. Yes.
Okay.
Calculus.
Someone is mentioning calculus. Calculus, who has mentioned calculus?
Kamal.
Oh, Ashok, eh?
Yes.
Okay. Calculus, talk about calculus, we have area approximation, where we have a trapezium method and also mid-ordinate rule. There's another one that we normally don't use a lot, but it is very important. It's called ile ya kuchora squares, na count full squares and incomplete squares. EOP is under area approximation, but it's not really calculus. So we talk about calculus, we talk about trapezium method and mid-ordinate methods of approximating an area. Then we go to differentiation and its applications. And then we also have
integration.
Lastly, we have integration. All these three topics are under calculus. So Ashok, exactly where do you want us to tackle, or we tackle everything here?
Your integration.
Integration. Okay, good. I've noted down integration. But remember, Ashok, also differentiation and its applications has been coming for the last 3 years. So actually, section 2. So ni vizuri pia hiyo ujue kama uko sawa ama kuna some practice you need.
Differentiation and integration.
Differentiation, integration.
Yeah.
Okay. I've seen Brian has given me a question already on kinematics. Thank you, Brian. I'm going to share it with the rest of the class.
Mixtures.
Mixtures. So that's topic number 3. Mixtures. Who's asking mixtures?
Japheth.
Yes, Japheth James. Japheth James,
Yes.
in talking about mixtures, is just part of the topic that has proportion, compound proportion, rates of work, and mixtures. I don't know whether it is only mixtures or even rates of work and compound proportion.
Mixtures.
Mixtures, specifically mixtures, eh?
Yes.
Commercial mathematics.
Yes, commercial arithmetic.
Yes.
Commercial arithmetic. Which part specifically? First of all, is it 2 or 1?
2.
Arithmetic 2. All of it. We have hire purchase. We have appreciation and depreciation, compound and simple interest, and we also have income tax. Is it all of it or just those parts that I've mentioned? Dennis Miller, talk. Dennis? Okay.
Appreciation and depreciation.
Appreciation and depreciation, eh?
Yes.
Good. Any other topic? Maybe we can start with this as we wait for more topics to come. Keep revising. Take this opportunity as these are very good opportunities that you can really confirm your A early. Yes? Someone talking?
Loci.
Locus. Locus, loci.
Yes.
Now, there's a question that we have been given by Brian. He has given me a question here on, it is part of applications of integration, kinematics. So if you have a pen and a paper with you, you can write the question. Don't know whether I'm able to share it. Let me see whether I can share. Okay. I believe we can see that question given to us by Brian. A particle moves in a straight line starting at point A with velocity of 10 meters. A particle moves in a straight line starting at point A with velocity of 10 meters. So V is equal to 10 meters per second. After t seconds, its acceleration is given as 3 minus 2t. Like that. And you're told it is a starting point A with velocity of 10 meters per second. Find the position of the particle when it comes to rest. Find the position of the particle when it comes to rest. Like that. A particle moves in a straight line starting at point A. Now, when a particle starts at point A, starting with 10 meters per second, so meaning that at point A, velocity is 10 meters per second. Those that I can get from the question. At point A with velocity of 10 meters per second after t seconds. So in this case, what is 0? Because, for example, if you differentiate this, you are told to find the position of the particle when it first comes to rest. Position means distance or displacement. So we are going to integrate this acceleration for us to get the velocity. If we differentiate 3 minus 2t, therefore velocity will be equal to 3t minus, is it t squared plus c? 3t minus t squared plus c. And remember, when v was 10, t was equal to 0. When v was 10, t was equal to 0. So if you substitute this starting point, when it was starting, the velocity was 10 meters at point A. That means it had traveled 0 seconds. So t0, v10. If you substitute this to get c, so therefore v will be equal to, v in 10, so 10 equals to 3 times 0 minus 0 squared plus c. So 10 is equals to c. That means that our c is 10. Our c is 10 in that case. So t minus t squared. So we are told to get the position. Alan, Ndwati, unanisikia?
It was breaking. The connection is your voice was breaking.
Can you now hear me?
Yes.
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 Okay.
Yes.
Okay. Muliacha kunisikia kutoka wapi? Nirudie tena.
Tangu swali ianze.
Nianze.
Hapo kwa C equals to 10.
Anza tu.
Oh, okay.
Hata swali hatukusikia.
Swali ya mtu
Anza tu mwalimu. Tulisikia mwalimu.
Swali kidogo kwa screen. Let me share the screen.
Mimi nilipotea kwa swali.
Ulipotea kwa swali. Please let's maintain the. Wewe Onyancha atakutoa klasi yangu mara moja. Wewe. Don't complain, Bwana Onyancha. Takutoa. Can you control your background noise? Tafadhali, so that we can be together. Now, the question I had shared on the screen here, let me share it once again. That's the question. A particle moves in a straight line starting at point A with a velocity of 10 meters per second. After t seconds, its acceleration a meters per square second is given by a is equals to 3 minus 2t. Find the position of the particle when it first comes to rest. This is a question of integration. We are going to integrate because we are coming from all the way acceleration to displacement, because we talk about position. Position is not velocity, position is displacement. So, and remember it is starting from point A when velocity is equals to 10 meters per second. Now, let me go back to class. And I believe you can hear me. Dennis Wafula, you can hear me? Sawa sawa. Okay. Now, I've said now A is equal to 3 minus 2t. For us to go back to velocity, we need to differentiate acceleration. So, we need to integrate acceleration. So if you integrate acceleration, you get v is equals to 3t minus t squared plus c. 3t minus t squared plus c. That's our v. Now, we are told when v was 10 meters at point A, it had not taken any time to travel. So we were starting at point A when v was 10 meters per second. Therefore, time was 0. So when v is 10, t is 0. We want to find this value of c. So can you come and substitute v and t? When v is 10, t is 0. And we know we are starting, if we are starting a journey, it means that you have not taken any time. That's why you're saying that t is 0. So come and substitute. So you get 10 is equals to 3 times 0 minus 0 squared plus c. You find your c as 10. So that means the equation for velocity will be equal to v is equals to 3t minus t squared plus 10. Ezra Duo. Duo Ezra?
Yes.
Umenisikia kila kitu hapo? Umesema?
Ndio na process.
Una process?
Yes.
Lakini so far umeelewa vile nimesema?
Yes.
So nimefika place ya v is equal to 3t minus t squared plus 10.
Yes, yes.
Tuko pamoja hapa ama nimekuacha nyuma?
Niko sawa.
Ian Joshua, tuko pamoja? Aya. Victor Kimani? Are we together?
Yes, we are together.
Usiweke picha yako hapo alafu wewe uende kunye uji huko. Let's be together. Najua kora zenu hapa. Weka picha yako na tuonane vizuri. Jua hata mimi mnaniona. Please, let's have a habit of putting, you are going to have Zoom meetings in the future when you become a CEO somewhere. Utakuwa najificha hivyo. Weka picha yako, be in a meeting, participate, so that tukue pamoja na lesson ikiisha tunashukuru Mungu. Now, at this point, I have equation for velocity. V is equal to 3t minus t squared plus 10. Now, we are told the question is asking this. Let me give you the question again. The question is asking, find the position of the particle when it first comes to rest. When it first comes to rest. Kuna hiyo word rest. Rest means it's going to stop. It will not move. Therefore, if it stops, then v will be 0 at that point. V will be 0. When something comes to rest, automatically unajua v is 0. So can we differentiate? Can we integrate this so that tupate the equation of displacement? Because the position means velocity. Let me consult Kimani Victor. Victor, unaonaje? Talk about position of the particle. Are you talking about speed or the distance?
Talking about distance.
Distance. Even me, I guessed it's distance. So if you differentiate, if you integrate this one, integrate v is equals to 3t minus t squared plus 10. What do we get? S is our displacement, is equals to, is it 3t over 2? 3t squared over 2 minus t cubed over 3 plus 10t plus c. Now, can we find the value of t when v is equal to 0? Can we find the value of t when v is equal to 0? Because at rest, v must be 0. So can we find the value of t when v is equal to 0? And v was 3t minus t squared plus 10. So what is the value of t when v is 0? Like that. So this is a quadratic equation. T squared minus 3t minus 10 equal to 0.
5 or -2.
Yes, who has gotten the value?
5 and negative 2.
Negative 2
5
or
and negative 2.
or 5.
So t is equal to 5 or t is equal to negative 2. So time cannot be negative. So ignore this. And you must write, tell the examiner, ignore this. So that now you say t is equals to 5. So that means when v is 0, your t will be 5. Therefore, your s is 3 over 2, 5 squared, minus 5 cubed over 3, plus 10 times 5. That should be your displacement now. So this will be 25 times 3. That is 75 over 2, 125 over 3, plus 50. Can someone compute that?
45.83.
45.83.
So 45.83. Is 3 recurring, ama inaisha?
Recurring.
Then you put your answer as a decimal. As a fraction, sorry. So it will be 45?
And 5 over 6.
5 over 6. Never leave your answer as a recurring decimal. Or if you insist as a recurring decimal, then uandike 45.83. Na hii 3 hapo weke dot. Hiyo 3 weke dot hapo. Maybe I can show you what I've done. With my dot, I don't know whether it is, you can see my dot. Hapo 3 nimeweka dot hapo.
Yes.
If you insist on the decimal, but weka value yako kwa fraction, uende zako. If you insist on the decimal, then you must indicate that 3 is recurring. Good. Brian, I don't know whether you are still in class, ama umejitoa.
Yes.
Yes, can you talk to us? Where you got the question, was there answers?
No.
At least you have gotten the way out, eh?
Yes, but
but
hapo kwa vile uli integrate velocity.
Oh, will integrate velocity.
There was plus c. Hiyo plus c imeenda wapi?
Hiyo plus c.
Yes.
This thing is coming to rest. it is coming to rest, so C will just be 0. C haitakuwa kitu. Tunaona hapa kuna 210T. So if, for example, if you say that at that rest pia, at that point, tumesema V itakuwa 0 at that point. Okay, velocity will be 0. But if you stop, this constant will not be there. So C will just be 0. So that's why you have seen me ignoring that C. And even if you look at the question, Brian, how we are going to get that C? Sometimes ni vizuri kufikiria na swali.
Hapo ndo ilikuwa inasumbua. Hapo C.
Unaona hiyo swali iko locked, huwezi pata C.
Sawa.
Okay. I have another question on that. But now this is application of differentiation. Maybe we can, if you have KMF, it is there in KMF, the year 2011, the one that was set in 2011. Maybe if you have KMF, you can go to that. The year 2011, the displacement S meters. The displacement S meters of a moving particle after t seconds is given by the displacement S meters of a moving particle after t seconds is given by S is equals to 2t cubed minus 5t squared plus 4t plus 2. I'll repeat. S is equals to 2t cubed minus 5t squared plus 4t plus 2. This is a displacement S meters of a moving particle after t seconds. You are told to determine the velocity of the particle when t is equal to 3. Determine velocity when t is equals to 3. Kimani, what do we do here? The first thing to be done. Ashok, I can see you are on. What the first thing that we should do? Actually, this is your area, your question on calculus. The first thing that we do is to differentiate, because, okay, we are moving from displacement to velocity. We differentiate. Yes, Malim. Malim?
Yeah, you differentiate the displacement and you get the velocity as 60 squared.
So what's our velocity, Malim?
28 meters per second.
Yes?
28 meters per second.
Oh, already you have differentiated now, make t is equal to 3.
Yeah.
Maybe you can take a step by step by differentiating first.
So after differentiating, you get V as 60 squared minus 10t plus 4.
Plus 4.
And then you substitute where there is t, you substitute by 3, since we are told after 3 seconds. So you will get the final answer as 28 meters per second.
Which is 18 minus 30 plus 4.
Yes.
Is that what you're getting?
Yes. Yes.
54 minus 30 plus 4.
Oh, 54 minus 30.
Yeah.
54 minus 30 plus 4. So it is 58 minus 30. So we get 28. That's correct. I hope all of us tumepata hiyo. And then second question, the value of t when the particle is momentarily at rest. The value of t when the particle is momentarily at rest. And I've mentioned when something is at rest, any object at rest, velocity will always be 0. So can you go and pick the velocity, equation of the velocity? V is equal to 60 squared minus 20 plus 4. Equate that one to 0. V is 0. So 6t squared minus 10t plus 4 is equal to 0. Let us factorize this quadratic equation.
T is 2 over 3.
Yes?
T is 1 or 2 over 3.
2 over 3 or 1.
T is 1 or 2 over 3.
Yes.
So all of them are positive. So we are going to get two different answers. T is equal to 1 or T is 2 over 3. But in case one of them was negative, then you have to tell the examiner that you are ignoring the negative time. Your time cannot be negative. Don't just keep it there as a negative and then you keep quiet. The displacement when the particle is momentarily at rest. So displacement, go back to the displacement equation, which was 2t cubed minus 5t squared plus 4t plus 2. So substitute there 1 and also substitute 2 over 3. So if you put there 1, what is your displacement? I'm getting 3 meters.
Yes.
Yes.
What about
Yes.
if you
Yes.
put
It is 3.
what about if you put 2t is equal to 2 over 3?
Get 3 1 over 27.
3 1 over?
27.
The last question is asking the acceleration of the particle when t is 3. Acceleration of the particle when t is 3. So acceleration tuna differentiate velocity. So velocity yetu ilikuwa v is equal to 6t squared minus 10t plus 4. Therefore acceleration will be, was differentiated, share with us. (12t minus 10).
Yes.
And then when
Yes.
t is equal to 3,
26 meters per second.
26.
26 meters per second.
Yes, 26 meters per second.
Now let's do another one of determining the turning points or the stationary points or maximum or minimum points. Let's pick one question here. If you have KMF again, I'm going to number 26. Number 26, that's what I'm going to. If you have KMF, number 26 was set in 2012. The equation of the curve y is equals to 2x cubed plus 3x squared. The equation of the curve is y is equals to 2x cubed plus 3x squared. A Roman 1, find the x-intercept of the curve. When we talk about x-intercept, is where the line is cutting the x-axis. And at that point, y is ever 0. Y is always equal to 0 at that point. So told to find the x-intercept of the curve. That means 2x cubed plus 3x squared should be equal to 0. So you can factor out x squared. We shall have 2x plus 3 is equal to 0. That means that x is 0 kwanza, or 2x plus 3 is equal to 0. So 2x is negative 3 divided by 2 by 2. So x is negative 1.5. 1.5. So x is negative 1.5 or x is 0. If x is 0, bado itaingiana. Y itakuwa 0. So don't forget your x is equal to 0. The two answers might be scoring simultaneously. Without one of them, you won't score the last mark. So ensure that you have the two answers, if that is the case. Then we go to the next, Roman 2, the Y-intercept. Now can someone find, yes?
Question.
Yes, Brian?
Vile umesema 2x squared plus 3 equals to 0.
2x cubed, sorry.
No, vile sasa ulikuwa na factorize. Then x ni 0, then 2x squared is equals to negative 3. then ukasema 2x squared equals to negative 1.5. Sasa
X,
no,
X,
x squared equals to negative 1.5.
X.
Ilikuwa 2x squared. Sasa.
It was, the question is, okay, let me just repeat again. Let me repeat. I have y is equals to 2x cubed plus 3x squared. Are you there, Brian?
Yes.
Then I have said that y is equal to 0. So I've said 2x cubed plus 3x squared is equal to 0.
Yes.
Then I've factored out x squared.
Oh, yes.
Uko sawa sasa? Good. Now from there you can continue back upate x is equal to negative 1.5. Anyone had another question? Someone had another question? Don't know who was he. Who was saying that I should repeat? Dennis Musioki, are you okay?
Yes.
Who is going to help us get the y-intercept of the curve? Who is going to explain to us? Austin Jura, why can't you take this chance and explain to us the y-intercept?
At the y-intercept, the x is supposed to be equals to 0. It's where the x cuts the, sorry, where the line cuts the
y-axis. Yes, Austin.
At the y-intercept is where x is equals to 0. But
so if you quit, what do you get? I don't know whether I'm the one who's not hearing Austin. Is it the whole class? Maxwell Mwangi, are you in class? Maxwell Mwangi? Donnell? Yes, Mwangi. Have you heard what Austin has said? No. Maxwell? It seems they're not in class.
Yes.
You have heard what Austin has said?
No.
Okay. Let me go to Leon Gisheru. If you're in class, you say present so that we're able to communicate. Leon Gisheru?
Present.
Have you heard what Austin is trying to explain?
Yeah.
Yes or no? Let me go to Chenjo. Chenjo, you are there? Chenjo?
Yes.
Okay.
Yes.
Chenjo, take us through the y-intercept of the curve.
Just a minute.
Yes? Change, I'm waiting for you. Na kama kuna shida unasema kuna shida alafu tunakuacha kwenda kwa wengine. Don't keep us waiting. Ila situsaidie basi utafutie hapo Y-intercept. Dennis.
Yes.
Utafutie Y-intercept basi. Y-intercept, we know that x is equals to 0.
Sitabakia tu kwa Y-intercept itakuwa 0.
Y-intercept itakuwa 0, si ndio? Aya, twende na wewe. B Roman 1. Usipotee. Determine the stationary points of the curve. Then hapo tunafanya nini?
Si kwanza una integrate hiyo equation unapata 6x squared plus 6x.
Okay, why are you integrating?
Because ndio upate ndio because at stationary point the gradient is equals to 0. Ndio useme 0 is equals to 6x plus 6x
Good.
squared plus 6x.
Good. Now, how do we get the gradient? Do we differentiate or we integrate? They know to engage.
They integrate.
We integrate. Kwanza leo ujichune masikio na ujisemee tukitafuta gradient tuna differentiate. Sawa Dennis? Put it down there. Put it down. Anytime we are talking about gradient function, we differentiate. So we are going to differentiate y is equals to 2x cubed plus 3. Yes?
My internet is not, I can't hear you. I'm not sure if it's me or everyone, but I can't hear you well.
Victor Kimani, unanisikia?
Yes, nakusikia vizuri.
Basi change ni internet yako tu ndio kuna shida maybe. Dennis Mbila pia unanisikia? Na tuko pamoja? So tumesema you differentiate, don't integrate, eh?
Yes.
So dy over dx here, Dennis, will be what?
6x squared plus 6x.
6x squared plus 6x. Correct. Yes. Now, na tulisema at stationary point, stroke maximum or minimum point, dy over dx is equal to 0. So can we equate this 6x squared plus 6x is equal to 0? Hey, Abdimajid, please behave. Mute, you can mute so that you don't give us the background noise. So if you factorize x, you find that 6x plus 6 is equal to 0. So first of all, x is 0. Ujue hivyo. Alafu tuko na 6x plus 6 is equal to 0. Therefore, 6x is equal to negative 6 divided by 6 hivyo. So x is negative 1.
Yes,
so we have two values here. X is either 0 or x is negative 1. I hope we are together. Dennis Wafula, unanisikia vizuri?
Yeah.
Now, so tushapata where our gradient or where the turning points are at x is equal to 0 or x is negative 1. Determine the stationary points of the curve. When you are asked about points, ukiuliziwa point, ujue hiyo ni coordinate wanatafuta. So a point must be in form of x, y. So if x is 0, what is our y? Go back to the equation of y. Substitute x is equal to 0 hapa. And it is very evident that when x is 0, y is also 0. That's what I'm getting. That means 0, 0. So I have point 0, 0. It is a stationary point. And I also have x negative 1. So when x is negative 1, ukienda pale kwa y itakuwa nini?
Go
1. So that means I have 0, 0. and I also have negative 1, 1, like that. Those are my two stationary points. Let's go to Roman 2, B Roman 2. B Roman 2 says, for each point in B above, determine whether it is maximum or minimum. Determine whether it is maximum or minimum. So I have point 0, 0, and I also have point negative 1, 1. So let's start with this point 0, 0. You draw that table. You draw the table, the value of x, and the value of dy over dx. When x is 0, let me share with you my table so that those who have forgotten, you can remind yourself. You can see my table.
Yes.
Good. If you can see the table, draw a table like that. A table that looks like that. Now, on your number line, unajua, when I have 0, on my left, I have negative 1. On my right, I have positive 1. But I want to advise you to use 0.5, a range of 0.5, because 1 is too wide. So to me, positive 0.5 or negative 0.5. Na hii unaweka kwa dy over dx, usiweke kwa y. Don't confuse the two. Weka kwa dy over dx. When x is 0, dy over dx pia ni 0. Hiyo tuliona. What about when x is negative 5? What do we get? Someone who is through? Austin, if you are through, can give us, when your x is negative 0.5, what is your dy over dx? Substitute it kwa hii dy over dx. Is 6x squared plus 6x.
To 12.
Austin, sijakusikia vizuri.
See, una substitute na hiyo x ni 0, on the other side it will be negative 1 and then the other side inakuwa 1. So, and since we found the first one is 0, substitute negative 1, inaingia 6 minus 6, so inakuwa 0.
Inakuwa 0 pia.
Yeah.
What about if you use negative 0.5?
Negative 0.
Tumia negative 0.5.
Negative 1.5.
Negative 1.5.
Yeah.
Negative 1.5. So Austin, unapata hiyo idea yenye nakwambia 1 is too wide. So usiwahi tumia 1 kwa it's advisable and safe. Usiwahi tumia 1. Tumia 0 point something, a range of 0 point something. 1 is too wide, anything can happen. Between 0 and 1, a curve can even change 3 times. So you might even find ikona two turning points between 0 and 1. So use a very, very small range for your answer to be okay. What about if you use positive 0.5 now? Positive 0.5.
4.5.
4.5. So this is giving us something that looks like a basin. Are we getting a minimum at that point?
Yes.
So minimum at 0, 0. Minimum at 0, 0. Let's go to negative 1, 1. Do the same again. Draw the table of X and put 1 there. Please ensure that we use 1.5 and 0.5. A range of 0.5. Let's have that habit. 0.5 tulishapata hapa ni positive 4.5. 1 dy over dx is 0. Sorry, negative 1, not 1.
Is it 1 or negative 1?
It is negative 1. Negative 1. So negative 1, we are going to use negative 0.5 and
negative 1.5.
Negative 1.5. Okay, tutumia negative 1.5. Negative 1.5 inakuja ngapi? Inakuja 5.
4.5.
4.5.
Good. What about negative 0.5? Tulishapata kwa ile ya kwanza.
Negative 1.5.
Negative 1.5. So are we getting inverted basin? Give us the maximum. So maximum at negative 1, 1. My friend, hiyo swali unaona hapo ni 10 marks. Na mimi naambia form 4 kila siku kupita hii mtihani ni rahisi. Ukifocus kwa swali kama hizo, hii pepa unamalizanga haraka sana. Unamaliza hii pepa haraka sana. So, at least I'm sure you have added or we have added value during this lesson. At least we have added something on what you knew before. We have just tackled kidogo to differentiation and its applications, which I want to use that one to give you the assignments. How many questions do you want to do between today and next week? When we shall have another lesson? Let me ask Gabriel Mukuru. Gabriel Mukuru, if you can hear me.
Yeah, I can hear you.
How many questions can you attempt? Kuanzia saa hii hadi next, hadi Monday. Tuko na lesson nyingine Monday.
5 to 10 up.
Let me pick 10 on the higher side. Eh?
Okay.
Gabriel, are you still on?
Yes.
Uko na KMF?
Hapana.
Let me talk to Joshua Ian. Ian Joshua, uko? Umerudi class?
Yes.
Hiyo KMF yako zimefika 2019?
Hii yangu pamoja ndio nimeweka na nimekuja kapotea.
Can you hear me, Joshua?
Yes, yes.
Number 28 to 37 uchukue picha urushe kwa class.
28 to 37.
Sawa. Na Kimani pia uweke hivyo northeast watu wa different classes. If Joshua kishaweka hapa kama kuna KMF uchukue urushe kwa different classes. So that kila mtu apate. So that next lesson we are going to revise these 10 questions first. Kama kuna shida ndo tutatatua, then we go to integration. Sasa vizuri. So ensure that you post those questions to your respective classes. I wish to stop there because it is time. Can have your lunch. Yes?
Sure, if it is possible, next time we use a board.
A board?
Yes.
That one we can arrange, because a board then I need a camera, something like that. Ama?
Andika kwa hiyo glass hapo nyuma.
Yes? Dennis Kimaita, unasemaje?
Andika kwa hiyo glass hapo nyuma na whiteboard marker.
Hapa nyuma, hapa.
Yeah.
Tutaongea. That's a good suggestion. Mangu is a big school. Hatuwezi kosa kamera, alafu nyote mnaona. Mangu ni shule kubwa. So that suggestion will be taken care of so that we are able to use a board so that we kwa class I are able to show on the board na nyinyi mnaona bila na workout.
Bana, mweza dining hall.
Ati nutunue gani? Ili ya DH.
Kwa dining hall.
Dining hall.
Haina shida, so long as umesha suggest hivyo, kuna management ambayo inafanya hii shughuli yote ya masomo inakuwa sawa. So mimi nikishawaambia hivyo, mimi kazi yangu ni kuja class, the way I normally come to your classes. Nikishafunza mimi nimeondoka.
Na payment mwalimu.
Payments wewe ndio unafaa unitumie pesa, nikutumie namba.
Nitumie mimi.
Wewe ondoka bana.
Ingie hapa kwangu haraka
bana.
Hebu chukua hiyo namba basi 0702.
Na mwalimu kwa serious.